Hello students, today's video is about the layers of the Earth, Earth's crust, and convection as empirical evidence for plate tectonics. The Earth's layers. The Earth's interior is divided into 4 layers: the crust, mantle, outer core, and inner core. The lithosphere is made up of the crust and upper mantle, and characteristics of this layer is it's about 80 kilometers deep and it's thinnest under the ocean. It's cold, solid, and rigid, and this is the layer of the Earth that we actually live on. The asthenosphere is the upper portion of the Earth's mantle, and its characteristics are that it extends from about 100 kilometers to 260 kilometers below crust of the Earth. It's partially molten, and it has ability to flow. You need to make sure that you draw and label a model of the Earth's layers in your journal. Make sure you answer this question time question before moving on. Earth's crust, plates, and continents. In 1965, J.T. Wilson proposed that Earth's crust is broken into separate sections called the lithospheric plates. Plates can carry the continents or carry parts of the ocean floor to fit closely together along plate boundaries. And remember, the lithosphere is actually the level of the Earth, or the layer of the Earth that we live on. Continents are a large part of the lithospheric plate and have moved over time and continue to move. And they move at a rate about 2 centimeters to 10 centimeters a year, which is the same amount of time it takes for nail growth to occur over an entire year. Wilson combined information about the seafloor spreading and Earth's place in continental drift into a single theory that he stated as the theory of plate tectonics. You can see in the picture here that you can see the continents, the outline of the continents underneath the different plates. The plates do not directly line up with the continents, but they do include the continents underneath them, and that's how some of them get their name. Convection as empirical evidence to support the theory of plate tectonics. Again, we have the asthenosphere. It's the top portion of the mantle. As you can see in this clip here, you see the asthenosphere here. And if I write in a color you can see, you probably would be able to see. There's the asthenosphere. It is the top portion of the mantle and has solid and liquid properties. There's temperature differences within the layer of the mantle, which causes convection currents that drive plate movement. Just like when hot meets cold, when we did the lab in the classroom, this is the same idea that's going on inside of the mantle. Then there was evidence of the seafloor spreading, and convection currents led to the theory of plate tectonics, which supports Wegener's theory of continental drift. So now we have the theory of plate tectonics that states that pieces of the Earth's lithosphere are in constant slow motion driven by convection currents in the mantle. And all of this, we need to always be able to relate back to forces on Earth, because there's always forces acting upon the Earth and things that are happening here on Earth. And now you may do a self-assessment. You need to answer these 4 questions in your science journal after your notes. And then here on the left you have some Google News regarding Earth's plates, and you could read different articles about that and be ready to discuss any of those in class, or ask questions, or just share any fun information you may have learned. Again, I do not take responsibility for any errors in this video because I'm doing it at my house. And I've done it 500 times. Just kidding. Y'all have a great evening or a great day, and I'll see you in class. Bye.